கேரளால நடந்த ஒரு காமெடி சம்பவம். முன்னாடி போன பைக்க வழிவிட சொல்லி காருக்காரரு ஹார்ன் அடிக்க அந்த பைக்கை நிப்பாட்டிட்டு
Hi all, good morning. Can you please confirm my voice is audible or not?
It's audible, sir.
Okay, and hope my screen also visible.
Yes, sir, visible.
Okay, thank you. So, actually, I shared some of the steps for Pyspark installation. Okay, so we'll discuss about these steps after 30 or 40 minutes. So first I want to cover some theoretical topics, Sandy. So once we completed the theoretical topics, then we'll go for the practicals. As part of discussing practicals, then we'll discuss about this installation. So if anyone facing the issues, I will tell you why you are facing the issues and how you can able to resolve those issues. We'll discuss those after 30 or 40 minutes. First, we'll start with our theoretical concepts. Okay. So as part of today's session, we are going to start discussing about big data concepts. And after that, we'll discuss about Hadoop concepts. Then we'll start discussing about Pyspark. So, okay, so we'll start discussing about big data concepts. Then we'll go to Hadoop concepts. Then we'll start discussing about Pyspark. After discussing all this, then we'll start the practicals and we'll discuss about the installation steps. This is the plan for today. So we'll continue. So we can able to say, so any idea what is the big data with your knowledge? So simply we can able to say like this. Big data refers to extremely large data. Not only large, we can able to say extremely large and complex data sets that cannot be easily managed and processed or analyzed with traditional data processing tools. So we can able to say big data is nothing but big data we can able to refers to extremely large and complex data sets that cannot be easily managed and processed or analyzed with the traditional or our data processing tools and methods only. So here we can able to say, if you remember, in previous days, we are having floppy disks. So which can able to store only 1 MB data or it can able to store only 2 MB data. After that, what happened? CDs came. After that, DVDs came. After that, pen drives came. Now we are having SSDs, which is nothing but our hard disk. So which is going to contain around 1 terabyte of data, or we are having 50 terabytes of data. So like this, every day, if you observe here, day by day, so compared to the last 10 years to till day, so what is happening here day by day? Your data is increasing or your data is decreasing? Our data is increasing very, very hugely. Earlier days, we are having the floppy disk, which we can able to store only 1 MB or 2 MB data. At that time, we are thinking this is more than enough for the purpose of storing the data. After that, CDs came, which can able to store around 700 to 800 MB data. After that, DVDs came, which can able to store around 3 GB data. After that, pen drives came. After that, SSDs came. So like that, day by day, technology is improving. At the same time, day by day, data also increasing very hugely. So here we can able to say big data is nothing but big data refers extremely large and complex data sets. So here we can able to say large in the sense we can able to call it as terabytes of data to petabytes of data. So we can able to say here big data refers extremely large and complex data set. Large in the sense we can able to call it as a terabytes of data to the petabytes of data that cannot be easily managed or processed or analyzed with the traditional data processing tools. What do you mean by traditional data processing tools? So earlier we are having traditional data processing tools like our databases, or we are having ETL tools. So with the help of the databases or with the help of the ETL tools, we can able to handle the data up to one level. But when you want to deal with the terabytes of data, or when you want to deal with the petabytes of the data, databases or ETL tools cannot able to handle that much of data. And whatever the data we are talking, that much of data, that data only simply we can able to call it as a big data. In the simple words, we can able to say, whenever we are dealing with very huge amount of data, or whenever we are dealing with very complex data, such kind of data simply we can able to call it as nothing but big data. And whenever we are going to discuss about big data, compulsory we need to understand 3 V's, or we are having the 5 V's. So actually we are having the 3 V's only, but nowadays people are adding other V's also. So we can able to call it as a 3 V's, or we can able to call it as a 5 V's only. So first one we can able to call it as volume. Second one we can able to call it as velocity. And next one is variety. And next one is value, and next one is nothing but veracity. So like this, actually first 3 are the important V's, but now people are adding the 2 more V's also, so we can able to say total 5 V's. All these are the theoretical concepts. Please try to focus to understand all these things. After 30-40 minutes we'll start with the practicals, then you can get some kind of interest. But before starting the practicals, compulsory we need to have some kind of theoretical knowledge. For the reason, first 30 to 40 minutes I'm going to focus on the theoretical topics. I know you will get the bored feeling only, but you need to have knowledge about all these kind of terminologies. For the reason, we are discussing all these theoretical topics. Okay. So volume is nothing but, as I mentioned already few minutes back, we can able to say big data involves massive amounts of data. So big data involves massive amount of data, and we can able to say it can range from terabytes of data to petabytes of data. And we can able to say traditional databases and tools are not equipped to handle such huge amount of data. So as part of discussing big data, we are discussing about 3 V's, or we can able to call it as a 5 V's. One of the V we can able to call it as nothing but volume. Now tell me, the big data, we are going to deal with huge volume of data, we are going to deal with the less volume of data. Obviously we can able to say in the big data we are going to deal with the massive amounts of data. It can able to range from terabytes of data to the petabytes of the data, and our normal traditional databases or traditional tools are not available to handle that much of data. That's the reason we are introducing some new tools as part of handling this big data, that we are going to cover after 20 minutes only. But first to try to understand what is the meaning of volume from the big data perspective. In the same way, next one is velocity. Coming to velocity side, we can able to say data is generated and collected at an unprecedented speed. Now tell me, nowadays we are getting the data very fastly, or we are getting the data very slowly. If you take the social media in the Twitter, so within the minute or within the second only, we are going to get the very huge amount of data. And if you take the YouTube also, in the YouTube also, what's happening every minute or every second, so many people are going to stream the data by depending on their requirements. Indirectly, we are getting the huge amount of data, and whatever the data is generating or whatever the data is collecting, that is coming with very high speed, that we can able to call it as nothing but unprecedented speed in the today's world. So we can able to take the example as social media posts, and we can able to take sensor data, and we can able to take example as online transactions. So all these are different examples we can able to understand. One is the social media post, and the other one is the sensor data. Other one is online transaction. Now, if you take the UPI, so earlier if you want to do the internet banking, we are doing the net banking every day 3-4 times. But once UPS came, what happening here? Everywhere we are using the UPS only. Because of that reason, online transactions are increased very hugely. At the same time, all these online transactions are happening very fast pace. Within the seconds only, banking system will get the huge number of transactions because of availability of UPIs. Indirectly, we can able to say nowadays we are getting the data hugely. At the same time, that data is coming very hugely, very fast. That kind of feature we can able to call it as nothing but velocity. In the same way, coming to variety of the data. So as part of dealing with big data, is coming with various formats of data, which includes structured data and unstructured data and semi-structured data. So we are going to get the different kinds of the data. As part of big data, we are going to deal with the different varieties of the data. So we can able to call it as structured data or semi-structured data, and we can able to call it as a unstructured data. Structured data is nothing but we can able to take the examples as tables. And coming to semi-structured data, we can able to take example as XML files and JSON files. In the same way, coming to unstructured data, we can able to take examples as videos, logs, and images. Now, when you are going to deal with the big data, we are going to deal with all these kind of varieties of the data. We are going to deal with the structured data, we are going to deal with the unstructured data, and also we are going to deal with the semi-structured data. That's the reason we are having the one of the feature called as nothing but variety. Variety is nothing but big data is going to deal with different formats of the data by depending on the requirement. That might be structured data or unstructured data, or that can be the semi-structured data also, and value. So this is the most important one. We can able to say this is important one, not from the developer side. This we can able to say from the perspective of the business. So what we can able to say, value is nothing but the most important we from the perspective of the business side. Why we are calling it as a business side? Why we are collecting all this data as part of our process? We are collecting all this data. After that, we are going to process the data. After that, we are converting unorganized data into organized format. On top of that data, our business is going to perform the analysis. That's the reason on top of this data, we are going to give the very, very high important value from the business perspective only. So here we can able to say, because business team will do all analysis by using this data only. So without having the data, business people cannot able to perform any kind of analysis. And also why we are dealing with a very huge amount of data, because as part of doing the analysis, we need to provide the current data and also we need to provide the historical data. For that reason, we need to deal with the very, very, very huge amount of data. But at the end, why we are using all this data? For the purpose of doing our business analysis. For that reason, we are calling it as a value for the data. Why we are giving the huge value? Because from the business side, they need to perform the analysis on top of the data. Without having the data, they cannot able to perform any kind of analysis. For that reason, we are giving very high importance, or we are giving the high value to the data. That's the reason we are calling one more V is nothing but value. So first one is volume, which is nothing but we are dealing with terabytes to petabytes of the data. Velocity, at very high speed we are getting the data nowadays, that we can able to call it as a velocity. And as part of big data, we are going to deal with the different formats of the data: structured data, semi-structured data, and also unstructured data, that we can able to call it as a variety. And coming to value, so from the business people side or from the business team side, we are giving the high value to the data, because on top of this data only we need to perform the analysis. For that reason, we are calling it as a high value on top of our data. In the same way, one more last we can able to call it as nothing but veracity, which is nothing but the truth or accuracy of the data. So whatever the data we are getting, how much truth it is, or what is the accuracy of the data, that kind of feature we can able to call it as a veracity. You are collecting the huge amount of data. By using that data, what need to happen? We need to get the truth values. At the same time, we need to get the accuracy values on top of your data. Then only that data we can able to use for the purpose of our analysis. That kind of truth or accuracy of the data, indirectly we can able to call it as a veracity. All these are the V's we need to understand. Whenever anyone is asking about the big data, simply we can able to say big data refers extremely large and complex data sets that can able to handle terabytes to petabytes of the data. And as part of big data, we are going to have the multiple V's. First one, volume. Next one is velocity, then variety, then value and veracity. All these are the different terminologies which we need to understand as part of learning about our big data concepts. Now here we need to understand few more statements. to manage and make sense of big data, we need to understand several key concepts and we need to use several key technologies. So we can able to say to manage and to maintain the big data. So what is going to happen here? Several key concepts at the same time, several technologies are emerging. So out of those things, we can able to say first one is nothing but distributed computing. Any cases, what is the meaning of distributed computing? When we are discussing about the cloud concepts at the beginning of the sessions, we discussed about the distributed computing. What is the meaning of distributed computing?
Distributing the tasks to multiple servers.
Correct, perfectly correct answer. So whatever the tasks we are dealing, we are distributing those tasks to across the nodes, or we are distributing those tasks to across the people. That kind of activity we can able to call it as a distributed computing. Now here from the big data side, we can able to say big data processing often relies on distributed computing frameworks. I'm facing some issue with my keyboard and just bear with me few seconds. Yeah, big data processing often relies on distributed computing frameworks, like we can able to say first one is Apache Hadoop and Apache Spark. So as part of dealing with the big data, so most of the times we are going to use the Apache Hadoop or Apache Spark. So in the next few minutes, we are going to discuss about what is the Hadoop and what is the Spark. But to deal with this kind of huge amount of data and to deal with this kind of variety of the data, we are going to introduce the distributed computing. As part of introducing the distributed computing, here we are using the Apache Hadoop and also we are using the Apache Spark. In the same way, here we need to think about data storage. So when we are coming to here distributed computing, why we are using for the purpose of processing the data only. But coming to here, when you are dealing with the huge amount of data, what we need to do here? We need to store the data, which we can able to call it as a data storage. We can able to say our traditional databases may not be suitable to deal with big data. Because in the traditional databases, we cannot able to store the petabytes of data or we cannot able to store the terabytes of data. For that reason, traditional databases are not suitable to deal with the big data. So for that reason, what's happening here is we are using.
Sir, actually, in BigQuery also we are dealing with terabytes of data, right?
Yeah.
So
if you see the statement here, what I'm telling, to manage and make sense of the big data, several key concepts and technologies are measured only. Earlier, we don't have the BigQuery. Now we are having the BigQuery. So with the help of the BigQuery, what we are doing here, we are dealing with the big data. Okay. So earlier we are using the traditional databases, like we are using the MySQL or SQL, these kind of things. But by using those MySQL and other databases, we cannot able to handle the huge amount of data. For that reason, now we are introducing our new databases. For example, from the cloud side, you can able to see we are using the BigQuery. Now with the help of the BigQuery, what we can do here, we can able to deal with the very huge amount of data. Indirectly with the help of the BigQuery, what we are doing here, we are dealing with the terabytes of data, or we can able to deal with the petabytes of data. But why BigQuery came into the picture? Earlier we are having the traditional databases, but suddenly why BigQuery came into the picture? Because by using the traditional databases, you cannot able to handle with the huge amount of data. To handle that kind of huge amount of data only, nowadays we are using the BigQuery. Not only BigQuery, we are using our Redshift or we are using the Snowflake. So like that, we are using the different kind of technologies. So that's the reason I given the statement to manage and make sense of the data. Several key concepts and also technologies are emerged. So here BigQuery we can able to call is a one of the technology, or we can able to call is a one of the GCP service. By using that, what we can do here, you can able to store very huge amount of data by depending on our requirement. Now coming to GCP side, we are having the BigQuery. In the same way, coming to AWS side, we are having the Redshift. All these why we are using for the purpose of dealing with our huge amount of data in the nowadays. We are dealing all these kind of different technologies. For that reason, here I'm saying that to deal with the big data, different technologies are emerging in the market. So one of the example, as you mentioned, BigQuery. Other example, we can able to call it as a Redshift. Like that, we are using the different technologies as part of dealing with all these kind of big data. Okay. And here we can able to say, here we are using distributed file systems like HDFS, which is nothing but Hadoop distributed file systems, and NoSQL databases like Cassandra and MongoDB. So for the purpose of dealing with this huge amount of data, what we are doing here, we are using the one of the file system called as nothing but HDFS, which we can able to call it as a Hadoop distributed file system. And also, if you want to deal with this kind of huge data, we can able to use the NoSQL databases like Cassandra and MongoDB. By using all these things, we can able to handle huge amount of data by depending on our requirements. Okay. Now, in the same way, just I will add the one more statement here. For the purpose of dealing with this kind of big data, we are using the cloud computing concepts. Here we can able to say many organizations are nowadays leveraging cloud platforms. What are the different cloud platforms we are having? AWS, Azure, and GCP. Why they are using this? Simply we can able to say to scale their big data operations. Why we are using the cloud storage here, cloud computing? Because cloud providers are providing storage features, and also they are providing processing features, and also they are providing the analytics feature. So see here, someone raised the question, so why we are having the BigQuery? BigQuery also can deal with a huge amount of data. That's the reason just I'm introducing the one more statement here, which is nothing but if you want to deal with the big data, we can able to use our cloud computing feature, which is nothing but in the many organizations nowadays, what's happening here, most of the organizations are moving to the cloud side, AWS or Azure or GCP. But why they are moving to the cloud side from the data engineering side, we can able to say to scale their big data operations. As part of cloud, what is happening here, they are only providing the storage feature, they are only providing the processing feature, they are only providing the analytics feature. For that reason, nowadays most of the companies are migrating to the cloud computing side. Now in the previous statement I mentioned that we are using the file system called as a Hadoop distributed file system. Now by using this file system, what we can do here, you can able to store very huge amount of data, but this is coming with the help of the Hadoop, or this is coming with the help of your big data. But once we are moving to the cloud, what will happen? Within the cloud, they are only providing the storage feature. For example, if you take the GCP, in the GCP, which is the service we are using for storage? In the GCP side, which is the service we are using for the storage?
Cloud storage.
We are using our GCS, which is nothing but Google Cloud Storage. Now tell me, Google Cloud Storage can able to deal with a very less amount of data, or it can able to deal with a very huge amount of data?
Yeah, huge.
Obviously, it can able to deal with the very huge amount of data. It can able to deal with petabytes or terabytes of data by depending on our requirement. But when you can able to use the GCP only, because whenever you are migrating to the cloud computing side, then only you can able to use the GCS. For example, if you are not using the cloud computing, if you are working on the on-premise system, on-premise system, if you want to deal with the huge amount of data, then we can able to use the Hadoop distributed file system. But as part of your project or as part of your organization, if you migrated to the cloud side, then what we can do here, within the cloud, you can able to get the storage features. Within the cloud, you can able to get the processing feature. Within the cloud only, you can able to get the analytics feature also. By using all these features, what we can do here, you can able to deal with the very huge amount of data by depending on our requirement. That is the meaning of the statement. As part of managing the big data, several technologies are emerged. At the same time, several concepts are also emerged. So technologies in the sense we can able to say we are getting the cloud for the purpose of dealing with the very huge data. Not only for dealing the data, we are having the so many other features in the cloud. But from the data engineering side, we can able to say to deal with the very huge amount of big data, we can able to use the cloud computing. With the help of the cloud platform, you can able to get the storage, you can able to get the processing, you can able to get the analytics. By using all these things, what we can do here, easily we can able to deal with the big data as part of our real-time system. Other than this, we can able to say next one is, sorry, I will add one more statement here. We can able to perform data integration activities. As part of data integration, we are integrating data from various sources. Now tell me, when you are going to deal with the data engineering side, or when we are going to deal with the big data side, we are going to get the data from the only one source, or we are going to get the data from the multiple sources?
Multiple
Definitely,
sources.
you are going to get the data from the multiple sources, and or we can able to say in real-time projects or while dealing with big data, we will get data from different sources in single format or different formats. We can able to get the data in the different formats. That might be CSV file or JSON file or XML file or Parquet file, whatever the type of the file and D. So please remember this, when we are going to deal with the big data or when we are going to work as a data engineer, in the real time what is going to happen, you are going to get the data from the different types of the sources. Don't assume we are going to get the data only from the single source only. You are going to get the data from the different types of the sources as part of our real-time system, or when we are dealing with the big data. And when we are getting the data from the different types of the sources, you can able to get the data in the different types of the formats. If you remember, we discussed about definition of data warehouse. What is the definition of data warehouse?
Data collected from the different
We
sources.
can able to say collection of data from
Different sources.
different types of the sources,
Integrated.
and we are converting the data into organized format for the purpose of doing analysis to take the decision. So this is the one of the definition, or this is the one of the statement we discussed as part of our previous classes. As a data engineer, regularly we are going to work in the data warehousing projects. In the data warehousing projects, we are going to deal with the huge amount of data. When we are going to deal with the huge amount of data, what we are doing here, we are going to collect the data from different types of the sources. After that, we are converting the data into the organized format for the purpose of doing analysis to take the decision. This collection of data from different types of the sources, indirectly we can able to call it as a data integration, which is nothing but you are integrating the data from different types of the sources. Then we are converting the data into the organized format for the purpose of doing our analysis and to take the decision. Now in the same way, just we can able to introduce one more terminology called as nothing but scalability. What is the meaning of scalability? And one more terminology is nothing but fault tolerant. So again, these two are the points again we discussed as part of our beginning of the classes. And scalability is nothing but, what is the meaning of scalability?
You can increase the horizontal scalability in the
by depending on our requirement,
vertical.
either we can able to increase the number of resources horizontally or vertically. Otherwise, if you want, we can able to decrease the number of resources either horizontally or vertically. That kind of feature only we can able to call it as a scalability. So we can able to say by depending on requirement, either we can able to increase or decrease number of resources either horizontally or vertically. This feature we can call it as scalability. Now, when we are going to deal with the big data also, obviously this feature will come into the picture. When we are going to deal with the big data, we have to maintain the so many number of nodes only. Now, whenever data is increasing, we need to increase the number of nodes. Whenever data is decreasing, we can able to decrease the number of nodes by depending on our requirement. That kind of feature only we can able to call it as a scalability. Now, in the same way, what is meant by fault tolerant? This is one more concept we discussed in the previous classes. What is meant by fault tolerant?
When one of the server is down, the other server will replace
Yeah,
it.
perfect, correct answer. So because of any reason, if one server or one node failed, what's going to happen? Other server or other node will take care of all the responsibilities of the first server or first node. Automatically it is going to take care of all the responsibilities of the first server and first node. That kind of feature only we can able to call it as a fault tolerant. Indirectly, all these are the different terminologies we need to understand as part of dealing with our big data. So first one is nothing but our distributed computing, data storage, how it is happening in the on-premise system. On the on-premise, we are going to use the HDFS, and we are introducing the cloud computing for the purpose of dealing with our big data. And as part of big data also, we are going to integrate the data from the different types of the sources. And as part of big data, we need to deal with the scalability. At the same time, we need to deal with the fault tolerant. All these are the different terminologies or different concepts we need to understand as part of discussing about our big data concepts. Now, in the same way, here we need to understand one more important thing. For the purpose of dealing with big data, we are going to use a framework called as Hadoop framework. So we are going to use a framework called as nothing but Hadoop framework. So simply we can able to say Hadoop is a powerful open source framework. So we can able to say Hadoop is a powerful open source framework which is designed to process and store and analyze large volumes of data across the clusters. We can able to say. So see here, when we are dealing with the big data, so what we are going to do here as part of dealing with the big data, mainly we need to remember two things only. One is storage, second one is nothing but processing. These two are the terminologies repetitively will come into the picture as part of dealing with our big data. Not only with the big data, whenever we are calling the data, obviously these two terminologies will come into the picture regularly. One is storage, second one is nothing but processing. Storage is nothing but how you can able to store the huge amount of data. Processing is nothing but how you can able to process the data after storing the data. These two are very, very important. We need to understand as part of dealing with our data or as part of dealing with our big data only. Now, as part of dealing with the big data, what we are doing here, we are going to use a framework called as a Hadoop framework. So we are given the statement, Hadoop is a powerful open source framework. So Hadoop is nothing but no need to purchase. It's a kind of a open source software, or we can able to call it a kind of a open source framework. How it is designed? This is designed for the purpose of storing the data and also for the purpose of analyzing our large volumes of the data. Generally, when we are going to deal with the large volumes of data, as part of big data, we are going to deal with the large volumes of data. For that reason, to handle that large volumes of data, we are using the framework called as nothing but Hadoop framework. By using the Hadoop framework, what we can do here, you can able to perform the storage operations. At the same time, you can able to perform the processing operations also. And for the purpose of doing the storage operations, we are going to use HDFS, or we can able to call it as Hadoop distributed framework, Hadoop distributed file system. So here, for the purpose of storing our huge volume of data, we are using the Hadoop framework. Within the Hadoop framework, we are having the one of the component called as nothing but HDFS, which is nothing but Hadoop distributed file system. Now, in the same way, for the purpose of processing the data, here we are going to use MR, or we can able to call it as nothing but MapReduce framework. So as part of using the Hadoop framework, for the purpose of doing processing on top of your data, we are using the MR, or we can able to call it as a MapReduce. If you want to store the data, what we are using here, we are using the component called as nothing but HDFS component, or we can able to call it as nothing but Hadoop distributed file system component. With the help of the HDFS, we can able to store very huge volume of the data. And here I will add the some more statements. First one, HDFS. HDFS is the storage system used by Hadoop. It is designed to store massive amounts of data across distributed cluster. So as I told you already, what is the purpose of HDFS here? For the purpose of storing the data, we are using the HDFS, and by using this, what we can do here, we can able to store the massive amount of data across our entire cluster. What is the meaning of cluster? Any idea? Simply we can able to say
Group of machines.
Collection of nodes or we can able to call it as a group of machines. For example, if you are having a single laptop, that we can able to call it as a normal laptop only. But if you are going to maintain the multiple laptops together, indirectly we can able to call it as nothing but cluster. In the same way, if you remember, as part of discussing about the GCP, we discussed about the compute engine. With the help of the compute engine, we created only one virtual machine. But for example, if you are going to create the group of virtual machines, and if you are going to enable communication between all these virtual machines, that simply we can able to call it as nothing but cluster. So simply we can able to say cluster is nothing but it's the group of the machines, or we can able to call it as a collection of the nodes only. Now as part of HDFS, what we are doing here, it is designed to store massive amounts of data across distributed cluster, which is nothing but if you are going to store the petabytes of the data, that data will be distributed to across multiple machines on top of your cluster. Cluster is nothing but it's a combination of multiple nodes, or it's a combination of the multiple machines. Whenever we are going to store the huge amount of data, automatically what will happen, that data will be distributing to all the nodes, and or we can able to say that data will be distributing to all the machines automatically. Why? How it is happening automatically? Because of using the HDFS. Where we are having the HDFS? HDFS we are having in the framework called as a Hadoop framework. Where we are using the Hadoop framework? We are using the Hadoop framework on top of our big data. Indirectly, everything is interlinked here. Don't get any kind of confusion. First, we discussed about big data. Now, to deal with the big data, we are using Hadoop framework. Now, within the Hadoop framework, we are discussing about one of the component called as a HDFS. What is the purpose of HDFS here? This we are using for the purpose of storage, not for the purpose of processing only. HDFS purely for the purpose of only storing the data. Whenever you want to perform any kind of processing, or whenever you want to perform any kind of transformations on top of your Hadoop framework, then we are going to use the MapReduce. With the help of the MapReduce only, you can able to perform the processing operation. But if you want to perform the storage operations, then we are going to use the HDFS, or we can able to call it as a Hadoop distributed file system. Okay. Now here we need to understand what all are key characteristics of HDFS. Again, here also we can able to say HDFS is fault tolerant. Which means it can able to handle hardware failures. Very easily. So what is the meaning of fault tolerant? As we discussed already, if any one of the machine is failed within the cluster, or if any one of the node failed within the cluster, automatically other machine or other node will come into the picture for the purpose of taking all the responsibilities of your first node or first machine. That kind of feature only we can able to call it as a fault tolerant. So as part of HDFS, we are getting the feature called as fault tolerant. With that, it can able to handle the hardware failures very easily. And second one, we need to understand within the HDFS, it is storing the data in the block based. It is having block based storage, which we can able to call it as nothing but whatever the data we are loading, that data is divided into fixed size blocks. Might be typically 128 MB or 256 MB. So whatever the data we are loading, your entire data will be dividing into the chunks, or we can able to call your data is dividing into the blocks only. Every block size can be 128 MB, or we can able to take it as a 256 MB. After chunking the data, then what will happen here? That the data will be distributed across the nodes in the cluster. As I told you earlier, as part of HDFS, we are going to use the multiple machines. Whatever the data we are loading, that data will be loading into all the machines in the distributed manner. As part of distributing the data, what will happen here? Your data is going to divide into the multiple chunks only. Every block or every chunk is nothing but is taken the 128 MB, or it is going to take the 256 MB. With that, your data is dividing into the multiple chunks. After that, your data is going to distribute to all the nodes on top of your cluster. In the same way, as top of HDFS, it is going to follow master slave architecture. As part of HDFS, it is going to follow the master slave architecture. So we can able to say HDFS has master slave architecture. with a single name node, which we can able to call it as master, that manages metadata and data nodes. Data nodes are nothing but we can able to call it as a slaves that stores the actual data blocks. So this is the one more important statement we need to understand. As part of HDFS, what's happening here? It is going to follow the master slave architecture. Master is nothing but, so we are having the cluster. Within the cluster, we are going to have so many number of nodes. Out of all these nodes, one node will act as master. It is going to contain all the metadata information. So your master node is going to contain all the metadata information and our slaves, or we can able to call it as nothing but data nodes, which contains actual data. So actually, as part of HDFS, we are going to have the master going to call it as but name node. In the name node, we can able to see all the metadata, and coming to slave nodes, which we can able to call it as a data nodes. In the data nodes only, we can able to see all our actual data. If you remember what meaning of metadata, any guesses?
Data about
Structure
data.
of the table.
Data about data.
What is the metadata?
Stores all.
Simply we can able to say data about data. So metadata is nothing but data about data. Now, for example, here I'm giving the values like this: 1,000. Now tell me here, this is the data I'm giving. What we need to do here, we provide on top of this data, we need to add the one more data. For example, here I'm adding, this is EID, this is e-name, this is salary. Now, by using the EID, you can able to understand what is the meaning of Srini and quality. Now, out of this whole data, which one we can able to call it as a metadata, which one we can able to call it as a actual data here? Which is the metadata, which is the actual data?
EAD minimum metadata.
Salary, this we can able to call it as a metadata, because by using these column names, we are defining the data called as a 1 and 2, Srini quality, and 1,000, 2,000. By using this data, you can able to define the other data that we can able to call it as a metadata. Metadata is nothing but data about the data. Now, what is the actual data here? These values we can able to call it as a actual data. So just for your understanding, I can able to say this is nothing but our metadata, and this we can able to call it as nothing but our actual data. Okay. Now, actually, as part of HDFS, what's happening here? It is following the master slave architecture. As part of master slave architecture, it is going to contain the master node and it is going to contain the slave node. Whatever the master node we are having, that we can able to call it as a name node. Whatever the slave node we are having, that we can able to call it as a data node. And in the master node, it is going to contain the metadata of your all the nodes only. In the same way, coming to slave nodes, it is going to contain the actual data. Just for your easy understanding, I will add like this. Master is nothing but name node. It is going to contain metadata. And coming to next one, we can able to call it as a slave, or we can able to call it as a data node, which is going to contain all our actual data. So here metadata is nothing but, this is from the table perspective, I given the example only. So from into HDFS side, as part of master slave architecture, here metadata is nothing but, it will contain all the details of slave nodes, or we can able to call it as a data nodes. Whatever the number of data nodes or whatever the number of slave nodes we are maintaining, it is going to contain all the slave nodes information, or it is going to contain all the data nodes information within your master node, because indirect is acting as a kind of a lead only. For example, if you are going to work in the real time, we are going to have a team lead. Definitely, as a team lead, what need to happen? He need to have all details of his team members. Okay, so how many members is having when he joined, what is their experience, what is their skill set, a person is strong in which area, a person is weak in which area, all this kind of information as a team lead he need to understand. With that only he can able to handle the team. In the same way, as part of master slave architecture, master is indirectly acting as a team lead. It is going to contain all the details of your slave nodes only. That's not that information only indirectly we can able to call it as a metadata. By using that metadata, what will happen? It can able to handle all the slave nodes as part of our master slave architecture. That's the reason we can able to call master is nothing but it's a kind of a name node which is going to contain all the metadata, and slave is nothing but it's a kind of a data node which is going to contain all the actual data. All these are the different terminologies which we need to understand when we are discussing about the HDFS. HDFS is a fault tolerant. Whatever the data we are storing in the HDFS, that is the kind of block based storage. At the same time, as part of HDFS, we are following the master slave architecture. Now in the same way, here we need to understand one more component called as nothing but MapReduce. So far we discussed about the HDFS component. In the same way, we need to understand about the MapReduce. Now you try to do the answer. What is the purpose of the MapReduce? As we discussed already a few minutes back.
Data
For
For the
processing.
purpose of storing or for the purpose of processing?
Processing.
We can able to say for the purpose of processing only. So we can able to say here like this. MapReduce is a programming model and processing engine for distributed data processing. See, if you observe everywhere, multiple times we are using the word called as a distributed. This is the one of the common terminology we need to use as part of our big data world, because everything is dealing with the distributed wave only. That's the reason at the beginning of the classes only we discussed about what is the meaning of the distributed. Whenever distributed is coming into the picture, what we need to think, all the things are, all the tasks or all the activities are going to happen in parallel. Earlier we discussed about in the HDFS data is storing in the distributed way. What it means indirectly? In the HDFS, data is storing in the distributed way. What it means indirectly? If you are loading the 1 terabyte of the data or 1 petabyte of the data will load sequentially to all the nodes, or the data will be loaded parallelly to all the nodes. What will happen as part of data loading?
Parallelly.
As part of your data loading, your data will load in parallel across all the nodes only. In the similar way, as part of MapReduce, what we are doing, we are performing the operation called as a data processing operation. This data processing operation also will happen in distributed way, or we can able to call it as in parallel way. In the big data world, nothing is going to happen in sequence. Everything is going to happen in parallel. But instead of calling it as a parallel, we are using the word called as a distributed. Now coming here, we can able to say as part of MapReduce. MapReduce is a programming model and A is a processing engine. And why we are using this? For the purpose of distributed data processing. And within the MapReduce, we can able to see some kind of components like this. First one is mapper. Second one is nothing but we can able to call it as a reducer. As part of MapReduce programming, the map phase processes and filters data, and it will populate key value pairs. So as part of this MapReduce programming, we are having the mainly two components only. One we can able to call it as a mapper. Second one we can able to call it as a reducer. As well, what I'm telling here is a kind of a programming model. Within this programming model, mainly we are going to have the two components. First one is the mapper component. Second one we can able to call it as a reducer component. As part of mapper component, what is going to happen here? As part of map phase, it is going to process the data and it is going to perform the filtering the data, or whatever the transformations we are applying, all those transformations are happening on top of your mapper. With that, it is going to populate the key value pairs as a result, and it will populate key value pairs as result. Now, as part of reduce phase, what will happen here is the reduce phase is going to aggregates and summarize the data based on key values. So in the first step, in the mapper phase, what's happening here? We are getting the key value pairs. After getting the key value pairs, in the reducer phase, what will happen here? Here in this phase, it is going to perform the aggregate operations, or it is going to perform the summary operations based on the key values. In the first step, we are getting the key values, right? On top of these key values, based on the key value, what will happen? It is going to perform the aggregate operation, or it is going to perform the summarize operation. Indirectly, we need to understand as part of map reduce, where all the aggregate operations are going to happen in the phase or in the component called as a reducer component, or in the reducer phase, it is performing all our aggregate operations. At the same time, where your data processing or filters are happening on top of your mapper phase or on top of your mapper component, all the processing of the data or all the filtering of the data is happening on your mapper phase. That's the reason this framework we can able to call it as a map reduce framework. Here we can able to see the two components. One we are calling it as a mapper. Second one we can able to call it as a reducer. In the simple words, we can able to say in the mapper phase, it is going to read the data and it is applying the filters. With that, it is going to populate the key value pairs. After that, in the reducer phase or in the reducer component, it is going to perform the aggregate operations and summary operations by depending on our requirement. Now, this mapper component and reducer component, both we can able to see in the map reduce model. Now, you tell me this map reduce model where we are going to see. We are discussing about map reduce, but where we are having this map reduce model?
Hadoop, big data.
So we can able to say in the Hadoop framework. That's the I'm telling you, don't get any kind of confusion, Sandy, and don't forget about the previous statements also. Here we are discussing about Hadoop framework. Within the Hadoop framework, we are having the concept called as a map reduce model, and why we are using this for the purpose of our processing the data. In the same way, within the Hadoop framework, we are having one more component called as a HDFS. Why we are using this? For the purpose of storing the data. And why we are using the Hadoop framework?
When we have the big data.
To deal with the big data, or to deal with the huge amount of data, or to deal with the complex amount of data, we are using the Hadoop framework. If you want, what I can do here, simply by giving these 3 lines of statement, we can go to the other topics, Sunday. But my intention is I want to cover each and every terminology which we are using in the big data or which we are using in the Hadoop side. With that, what will happen? You can able to understand the practicals, whatever we are going to perform very easily. That's the reason I am trying to spend more amount of time today on the theoretical concepts. Here we discussed about big data. Within the big data, we are using the framework called as a Hadoop framework. Within the Hadoop framework, we are having the 2 components. One is the map reduce and other one is the HDFS. Why we are using the map reduce? For the purpose of processing the data. Why we are using the HDFS? For the purpose of storing the data, we are using the HDFS component. Okay. Now, in the same way, here we need to understand Hadoop ecosystem components, or we need to understand about what all are the Hadoop stack. This is the one terminology you can able to listen as part of your interview process, or as part of your when you are searching for the jobs. In the summary or in the job summary, they will mention that you should have knowledge on the big data stack, or you should have knowledge on the Hadoop stack, or you should have knowledge on the Hadoop ecosystem component. This is the one of the word we can able to see as part of searching for jobs on the big data. So that's the reason just I'm trying to explain what is meant by Hadoop ecosystem components, or what is meant by Hadoop stack. And so here we can able to say like this. Hadoop has a rich ecosystem. Tools and libraries that extend its capabilities to deal with the data. So to deal with the data within the Hadoop side, we are having a rich ecosystem of the tools or rich ecosystem of the libraries. And by using that, what we can do here, we can able to deal with the data very easily. So just I'm giving some list here. We are having the Hive, we are having Pig, we are having HBase, we are having Spark, we are having Scoop, and we are having Kafka, and we are having Woozy, and we are having Flu. So like this, we are having the different number of tools, or we can able to call, we are having different libraries as part of our Hadoop ecosystem side. So just I'm giving some examples here. Hive, Pig, HBase, Spark, Scoop, Kafka, Woozy, Flume. Like this, we are having n number of tools or n number of libraries we are having. But what is the purpose of all these tools? For the purpose of dealing with the data within the Hadoop ecosystem, we are having the multiple number of tools, and by using these tools, we can able to perform the different activities. If you take Hive, for example, by using this, it's a the data warehouse, and we can able to say SQL like query language for Hadoop. Actually, in the GCP side, if you want to deal with the data warehouse system, what is the service we can able to use? We can able to use the service called as a BigQuery in the GCP side. But coming to Hadoop side, if you want to deal with the data warehouse side, then what we can do here? We can able to use the one of the tool called as nothing but Hive. With the help of the Hive, we can able to maintain the data warehouse system. On top of the Hive, we are having a language called as nothing but HQL. Any guesses what is the meaning of HQL?
Hadoop
It's
with
a Hive query
SQL.
language, not Hadoop, but it's a Hive query language. In the Hive, we are having a language called as a Hive query language. With the help of that, we can able to write the queries, and by writing the queries, we can able to perform the data processing operation. In the same way, we are having the one more component or tool called as a Pig. This is a high-level scripting language for data processing on Hadoop. So if you want to perform the data processing on top of the Hadoop, we are having the one more high-level scripting library or language called as a Pig. With the help of this also, we can able to perform the data processing on top of the Hadoop. In the same way, we are having a HBase, which is nothing but this is a NoSQL database that provides real-time read and write access to Hadoop data. So coming to HBase, we can able to say it's a kind of a NoSQL database. With the help of this, we can able to provide real-time read and write operations on top of your Hadoop data. A very important one, Spark. We can able to say here a fast and in-memory data processing engine. Often used with Hadoop for real-time and batch processing. So here we can able to say we are having the Spark. This is the one of the important component which we are going to use as part of our real-time projects. And as part of Spark, it's a kind of a fast and in-memory data processing engine. At the same time, it is going to deal with the real-time data, and also it is going to deal with the batch processing data. Now you try to give the answer. In the GCP side, if you want to deal with the real-time data, what is the service we are going to use?
PubSub.
We are going to use the PubSub. Okay, indirectly, if you want to deal with the streaming data, or if you want to deal with the real-time data in the GCP, we can able to use the PubSub. In the same way, by using the Spark also, what we can do, if you want, we can able to deal with the real-time data, or we can able to deal with the streaming data. Within the Spark, we are having the multiple components only. By using the Spark, we can able to perform the SQL operations. By using the Spark, we can able to deal with the real-time data operations. By using the Spark, we can able to perform the batch processing operations. By using the Spark, we can able to perform the machine learning operations. Like that, with the Spark, we can able to perform the multiple activities. But we will discuss about the Spark in detail after 20 minutes or 30 minutes, or in the tomorrow session. We are going to discuss about in detail about the Spark. But at the high level, we can able to say Spark is a fast in-memory data processing engine which we are using for real-time and batch processing. In the same way, we are having the Scoop. This is a tool for transferring data between Hadoop and relational databases. So whenever there is the requirement, if you want to transfer data between relational databases and to Hadoop, or Hadoop to relational databases, then we are having the one of the component or one of the tool called as nothing but Scoop. With the help of the Scoop, you can able to perform the data transfer between Hadoop and the relational databases. Now you try to give the answer. In the GCP side, what is the service we are having to deal with the SQL?
BigQuery.
No. To deal with the relational databases, I'm changing my statement. Whenever you want to deal with the relational databases in the GCP side, what is the service we can able to use?
Cloud
we can able to use the
Yes,
service
cloud
called as a Cloud SQL.
Cloud
With the help of the Cloud SQL, you can able to deal with the relational databases by depending on our requirement. But in the Hadoop side, if you want to transfer data between the Hadoop to relational databases, or if you want to transfer data from relational databases to the Hadoop, then we can able to use the tool called as nothing but Scoop. In the same way, we are having the one more tool called as nothing but Kafka. So with the help of this tool used for the purpose of streaming data into Hadoop. So if you want to stream the data, then we can able to use one more tool called as nothing but Kafka. With the help of the Spark, we can able to perform the streaming operations. With the help of the Kafka also, we can able to perform the streaming operation. In the same way, with the help of the Flume also, we can able to perform the streaming operations by depending on our requirement. Now in the same way, we are having the one more tool called as nothing but Uzi. With the help of this, by using this tool, we can able to schedule the jobs. On top of Hadoop system, if you want to schedule the jobs or if you want to schedule the workflows, then we can able to use the tool called as nothing but Uzi. Now coming to batch 19 people, try to give the answer. In the GCP side, for the purpose of scheduling the jobs or for the purpose of providing the dependencies on the jobs, what is the tool we are using?
Airflow.
Airflow.
Airflow Composer.
Composer.
We are using the
Cloud
Composer.
Composer.
Within the Composer, we are using the
Cloud.
Airflow. Coming to batch 20 people, don't worry. So in the coming classes, we are going to discuss about one of the service called as a Composer. But coming to batch 19 people, already we discussed about the service called as a Composer. In the GCP side, we are having the Composer. But coming to Hadoop side, for the purpose of doing the orchestration, we are using the tool called as nothing but Uzi. So like this, we are having the multiple number of tools available on top of our Hadoop system, Hadoop ecosystem, or all these tools only we can able to call it as a Hadoop stack. For every tool, we are having the different purposes only. By depending on our requirement, we need to pick the tool. With that, we can able to deal our Hadoop ecosystem on top of our on-premise. But if you are going to deal with the cloud, in the cloud, if you want to deal with the Hive, we are having the BigQuery in the Google side. If you want to deal with the Uzi, we are having the Airflow or Composer. And if you want to deal with the Scoop, we are having the Cloud SQL. So all these are the tools we are discussing on top of the cloud or on top of the Hadoop. All these are the tools available in the Hadoop ecosystem, or all these are the tools which are available on the cloud side.
Hadoop ecosystem.
All about tools are available on Hadoop ecosystem. Don't get the confusion. These are not from cloud side. People will get the confusion for this statement. So see here, whatever the tools we are discussing, all these are the tools we are discussing from the Hadoop ecosystem side. And within the Hadoop, we are having these many number of the tools. By using all these tools, we can able to perform our data storage operations, or we can able to perform the data processing operations, or we can able to perform streaming operations, or we can able to perform batch processing operations. For the purpose of doing all such kind of operations within the Hadoop ecosystem, we are having the multiple tools. With the help of these tools, we can able to handle the Hadoop framework by depending on our requirements. Okay. Up to here, any questions or confusions, please ask me.
Sir, this tool.
Sir, I have a question here.
Yeah, please.
So,
go ahead,
map
whatever.
reduce is also for data processing.
Yeah, correct. Yeah, that is also one of the tool we are having in the Hadoop ecosystem. So here I can able to add.
Yeah, in Spark, Spark also is for data processing only.
Yeah, Spark also for data processing, and MapReduce also for Spark data processing only. When I'm going to start discussing, yeah, that's the thing. So when I'm going to start discussing about the Spark, that is the one of the topic we are going to cover, which is nothing but what is difference between Spark and MR. Or I will give the statement, instead of using MR, why we are going to use Spark for data processing. This is the one of the topic which we are going to cover as part of discussing about the Spark. Okay, just give me some time. If possible, in the today's session we'll discuss about this topic. Otherwise, in the tomorrow session we are going to start discussing about the Spark. And as part of discussing about the Spark, definitely we need to understand what is the difference between Spark and MR, and also we need to understand, instead of using the MR, why we are using the Spark for the data processing, and we need to understand what all are the disadvantages we are having on top of the MR. All these topics I will cover as as part of discussing about the Spark, because here purely we are focusing on what are the different components we are having in the Hadoop. That's the reason I am not discussing those differences here. Definitely we'll cover this topic as part of discussing about the Spark. Is it fine?
Okay.
Okay. Any other questions up to here?
Sir, this tool is used for the purpose of stream data into Hadoop, right? Flume.
Yes.
Which means by using Flume, we are loading live data into the Hadoop.
Yes. In the Hadoop, where you are going to load the data, you only try to give the answer. In the Hadoop, where we are going to load the data? In the HDFS. Whenever we are saying the loading the data or storing the data, simply we can able to say use the word called as a HDFS. Indirectly, with the help of the Flume, you can able to perform the streaming operation. By doing the streaming operation, we are going to load the data. Where we are loading the data in the Hadoop, we are loading the entire data into our HDFS, or we can able to call it as a Hadoop distributed file system.
And data processing means where we perform all the aggregation operations.
Yes, perfectly correct answer. So you are doing the filtering, or you are converting one format of data into other format, or you are performing the aggregate operations, or you are going to perform the join operations. All these operations only we can able to call it as a data processing. The data processing, how we can able to perform in the Hadoop side? By using the MR, or we are going to use the one more framework called as a Spark. With the help of the Spark or MR, we can able to perform the data processing operation. But with the help of the Flume, what's happening here? It is not storing the data, and also it is not performing any data processing operation. Flume is a tool which we are using to handle the streaming data. With the help of the Flume, you can able to get the stream data. That stream data we are storing on top of your Hadoop or on top of your HDFS file system. After that, on top of that data, if you want to perform any kind of data processing operation, then either we can able to use the MR or we can able to use the Spark. With that, we can able to perform the data processing operation. As part of data processing, you can able to perform the aggregations or joins or filtering operation. Any kind of operations we can able to perform as part of our data processing operations.
Sir, HDFS means we are using it on premises, right? So
Yes,
all these operations we are doing on premises only.
Yes, correct. Actually, coming to Spark, you can able to use the Spark on-premise. Otherwise, if you want, we can able to use the Spark on top of the cloud also. On top of the cloud, if you want to use the Spark, how we are going to use that we are going to discuss in the coming classes only. But on the on-premise, if you want to do the data processing, then if you want, we can able to use the Spark, or we can able to use the MR by depending on our convenience.
So here one clarification, sir.
Yeah,
so if it is having the on-premise side Hadoop, like this Hadoop's big data, and it's a cloud, if you are migrating, then only this all concept will come to the picture, sir.
No. See, on top of the Hadoop system, for example, if you are maintaining the Hadoop system on the on-premise, then we are going to use all these things.
Okay.
Okay. Now, if you want, what we can do here, we can able to replicate the same Hadoop system on top of the cloud side also. Now, you try to give the answer based on your understanding. In the cloud side, if you want to deal with the Hadoop ecosystem, coming to batch 19, people try to give the answer batch 19. So, in the cloud side or in the GCP side, if you want to deal with the Hadoop ecosystem, what is the service we are going to use?
Data proc.
So we can able to say we are going to use the data proc. If you remember in the previous classes we discussed already, with the help of the data proc, what we can do here, we can able to replicate the Hadoop ecosystem on top of your cloud side also. Now, by using the data proc, when we are going to replicate the Hadoop ecosystem on the GCP, then in that Hadoop ecosystem, what we can do, if you want, we can able to use all these tools by depending on our requirement or by depending on our convenience. Now, for example, if we are not using the data proc cluster, then what we can do here, you can able to maintain this Hadoop ecosystem on top of the on-premise. On the on-premise, you can able to use all these tools for the purpose of processing the data by depending on our requirements. Is it clear?
Sir, what's the difference between the big data and BigQuery? Sir?
So coming to BigQuery, why we are using it for the purpose of maintaining our data warehouse systems, we are maintaining our BigQuery. Now, what is the big data here? Big data is a technology or it's a kind of a concept? It's a concept. Okay, so whenever we are going to deal with a very huge amount of data, such kind of data, we are calling it as a big data. There is no difference between the big data and BigQuery only. So big data is completely different and BigQuery is a completely different. Now tell me, BigQuery is a concept or BigQuery is a kind of a service or technology? It's a service, or we can able to call it's a kind of a technology. Why we are using the BigQuery? For the purpose of building our data warehouse system, we are using the BigQuery. Coming to big data is a kind of a concept. Okay, whenever we are going to deal with the very huge amount of data, or whenever we are going to deal with the different formats of data like structured data, or unstructured data, or semi-structured data, such kind of data we can able to call it as a big data. Now, to handle the big data, what we are doing here? We are using the Hadoop framework. Within the Hadoop framework, for the purpose of storing the data, we are using the HDFS. For the purpose of processing the data, we are using the MR. Other than that, we are having the multiple tools on top of your Hadoop ecosystem. By depending on our requirements, we can able to pick any one of the tool as part of dealing our data as part of our Hadoop framework. Okay. Any other questions?
Yeah. As a cloud data engineer, where we will use this big data, sir?
We will not use all this. So actually, whatever the tools I mentioned here, we are not going to use all these tools as a data engineer, as a cloud data engineer. But as a cloud data engineer, you need to have some basic knowledge about what is the HDFS. At the same time, you need to have knowledge about the Spark, because as a data engineer, cloud data engineer, we are going to write the Spark programming as part of our real-time projects. For the reason, out of all these, we are going to focus on the Spark. With the help of the Spark, we are going to perform the data processing operations as a cloud data engineer. But just for the knowledge perspective, we are discussing about what are the available tools we are having in the Hadoop side, or what are the available tools we are having in the big data side.
Okay, sir, clear.
Okay.
Thank you.
See,
So
for
we are
example, if
not-
you are not going to discuss all these things, what will happen is in the real time, suddenly those people are going to use the terminology like we need to deal with the big data, or we need to deal with the HDFS, or we need to deal with the Spark. So suddenly what will happen? You can able to get a lot of confusion if you are not having knowledge about all these kind of terminologies. For that reason, we are spending this much of time to understand all these kind of terminologies on top of the big data or on top of the Hadoop side.
So we are not using big data in real time, right?
No, we are using the big data in the real time, but we are using the big data not on the on-premise. We are using the big data on top of the cloud.
Okay.
Okay. Any other questions? Okay. If no questions, Andy, now I hope already you people are messed up with the theoretical topics. Now we'll start with the practical thing. First question. Morning I given the steps. How many of you succeeded to complete all those steps? Or anyone facing any issues? No answer means what I need to take here. Yes or no?
Yes, first completed the second issues.
Okay. Where you are facing the issues. So I will tell you like this and otherwise. Just I will explain quickly what we need to do. So all these are very straightforward steps. That's the reason. Just I given all the steps in the Telegram group. But if you are facing any issues, definitely we can discuss all these things in the class also. No issues here. Only for the purpose of saving the time, I given all these steps in the Telegram group. So all these are the straightforward. I will explain one by one. So what is the first one? If you want to work on the Spark side, we need to install the Java. So don't think that we are writing the Java code. We are not writing any kind of Java code, but in the backend as part of the Spark, it is going to use the Java. That's the reason. First step is nothing but we need to install the Java. For the purpose of installation of the Java, I uploaded the Java software on top of our Infinity. If you go to the Infinity side, so see here I given the Java download. Here you can able to see the .exe file. Please download the .exe file. Just double click on next, and with that what will happen? You can able to install the Java. That is the first step I given as part of my in our Telegram group. So first step, download the JDK from the Infinity and install it. After that, please verify the path. As part of installation, please verify in which path it is installing, because on top of that path we need to define the environment variables. And for the reason, as part of installation, please verify in which path your Java is installing. Please just make a note of that path, because that is the path we are using in the second step and third step. That's the reason, as part of installation, please verify in which path Java is installing. Okay, this is the step one. Now coming to second step, after completion of your Java installation, we need to set up the environment variables. And now if you want to set up the environment variables, just we need to go to start, search for environment variables, click on this, click on environment variables. Now see, in the top section and bottom section, we need to go to the bottom section. And please go to the bottom section. In the bottom section, click on new. Once we click on the new, it is asking the variable name. and also it is asking the variable value. Coming to variable name, we need to pass the Java underscore home. If you observe, given already. So in the variable name, you need to give it as a Java underscore home. That is the value we need to provide. Coming to variable value, in the step 1, whatever the path you noted, that is the path we need to provide on top of your variable value in the environment variables. Here we need to provide Java underscore home. Please, you can copy paste this one. Don't give the small letters only. Please give all as a capital letters. Don't type. Please copy the information from the steps to your variable name. After that, here I need to provide the variable value. Whatever the path you saw in the step 1, that is the path we need to provide. Otherwise, what you can do here is just you can go to your C drive. In the C drive, go to the program files. Within the program files, you can able to go to Java. Within the Java folder, you can able to see JDK and JRE. So in this, take the JDK, double click on that. Now this is the path we need to provide. This one. Just you can copy this and provide it here. So you need to provide the variable name is nothing but Java underscore home, and variable value we need to provide like this. So this variable path, this is the path I am having in my system, but in your system might be it is little bit different. That's the reason. Please verify the path properly and provide the path information on top of your environment variables. This is the step 1 in the environment variable. After that, here by default you can able to see one variable called as a path. Just double click on that. After that, here we need to add this value. So here also you need to click on new. Here also click on new. After that, here you have to give it as percentile Java underscore home percentile / bin. So this is the value we need to provide under the path. That information also I clearly mentioned on top of the steps only. Double click on path in the system variable. Click on new. After that, just to copy paste this information. Don't try to type. As part of typing, if you are giving any kind of mistake values, automatically what will happen, you can able to get the error in the next steps only. For that reason, instead of typing, please copy paste this information. You need to click on the path. Just I will show you one more time. Double click on path, then click on new. Here, please copy paste whatever the info we are having in the steps. Okay, so this is the way you can able to complete your Java installation. After completion of all these steps only, if you want to verify whether Java installed properly or not, what we can do, simply we can able to open the command prompt. In the command prompt, just give it as Java space -version. If you are giving this command, it can able to get the output is like this: Java version 1.8.0, which is nothing but if you are getting this kind of output, with that we can able to say Java installed properly. At the same time, we defined all the environment variables also properly on top of your system. Okay, any questions on top of the part 1, please ask me, or anyone facing the issues in the part 1 also, please ask me. Anyone facing the issues in the part 1? No, very good. See, again, I am repeating the same thing. It's a kind of a very straightforward operations, and no need to do any extra operations here. Just you have to download the software from the Infinity. Just double click on the file, click on next. With that, you can able to install the Java. After that, we need to define the environment variables. In the environment variables, we need to define the variable called as a Java underscore home. After that, in the path variable, we need to add this value by click on the new button. These are all the steps we need to perform as part of our part 1. Now coming to part 2, as part of part 2, what we are doing here is we are replicating our Spark in our system. For that, you need to install the Spark. For the purpose of installation, just you have to provide this URL in the browser. Once you are going to provide this URL, automatically what will happen, it will start the download only. So once you are going to provide this URL in the browser, automatically it will download the required software for your Spark. After installation of the Spark, here no need to perform any kind of installation. Whatever the zip file it is downloaded, we need to perform the unzip operation. If you see here in my system, this is Spark. So within the Spark, so whatever the zip file we are getting, just we need to perform the unzip operation on top of the zip file. Now, after completion of the unzip,
The voice breaking.
Is it fine now? Is it fine
Yeah, we
now?
last 20 seconds audio actually. Can you please repeat?
Okay, other people are also facing the same issue. Only one person facing this issue.
It's
No,
audible.
sir. It's fine, sir.
Yeah, I think it's a network issue from your side only. So can you please disconnect and connect once, if possible, because other people are able to hear my voice properly.
Okay, sir.
Okay. Yeah. Now see here. So this is the URL we need to provide. And once you given this URL, automatically what will happen? It will download the software on top of your laptop in the downloads folder. Now here, just you need to perform the unzip operation. Now please focus here, and this is the one of the very important step. Most of the people are going to do the mistake here only. Here you need to click on the extract. With that, what will happen? You are extracting all the files from the zip folder. Once we are going to perform the extract, what will happen here is it is creating the folder. Whatever the name we are having for the zip file, see with the same name, it is creating the folder like this. Now here I given the name like this. Here I given the step. Unzip the download zip file. This is the step 2. After that, you need to rename the folder from this name to Spark. Okay, so we need to rename this whole name with the Spark. But if you observe here, this is the folder which is creating after performing the unzip operation. If you go to the inside folder, see what's happening. Within the folder, what we are having? Again, we are having the one more folder. This folder also having the same name only. Now, most of the people, what they are doing here is they are giving the renaming this one, but that is the completely wrong operation. Please listen properly. Once you are going to perform the unzip operation, it will create the folder with this name. Within the folder, you can able to see the one more folder with the same name only. For that reason, here in the subfolder, whatever the name we are having, this name you need to replace with the Spark. Please take care of this step very proper way. Otherwise, you can able to get the errors. Just I'm repeating one more time. As part of doing the unzip operation, once we are going to perform the unzip with the same name, it will create the folder like this. Now, if you double click on this folder, within the folder, you can able to see the folder name like this. Now, instead of having this folder name, we need to change it as a Spark. Okay. Now, if you double click on top of this folder, now within this folder, you can able to see the bin folder. Then you can able to see the lib folder, and you can able to see one more folder as a conf folder. Like that, you can able to see the so many number of subfolders only. But here our main intention is nothing but whatever the folder we are having in the subfolder, that folder name you have to change it as a Spark. This is the very important step. If you are doing the mistake here, automatically what will happen? You cannot able to see the Pyspark on top of your system. If you are having any confusion on top of this step, please let me know. I will explain one more time. Just I'm repeating. You need to perform the unzip operation after completion of the download. Once we are going to perform the unzip operation, then it is going to create the folder like this. Now within this folder, again you can able to see the subfolder with the same name. For the subfolder, we are given the name called as a Spark. In the Spark, by default, you can able to see bin folder, conf folder, lib folder. All those folders information you can able to see by default. Now one more section I can able to give only. Now whatever the Spark folder you are having, if you want, you can able to cut this folder. Control X, cut, then paste it in the any other folder in the drive. Just what I did here, whatever the Spark folder we renamed, I cut that folder from that path and I pasted in the D drive or E drive or F drive, wherever you are having your convenience. Please paste into any one of the drive. What is the reason why we are doing this activity? Any guesses? Very simple, because instead of having our working softwares in the downloads folder, better to have this in the D drive or E drive or F drive only, because sometimes what we will do, we are going to clean up our download folder. When you are going to clean up the download folder, by mistake, if you are going to delete this folder, what will happen? You cannot able to work on the Spark. For that reason, just what I'm suggesting here is, whatever the folder you renamed in the previous step, just cut and paste that folder into the other path. With that, you can able to work on the Pyspark after 1 month or 2 months also, by depending on your convenience. Any questions up to here, please ask me.
So after extracting the zip file, I didn't go to the subfolder.
Yeah.
When I
Now, if you're
open
not
that,
getting, yeah, very good. And if you're not getting the subfolder, then whatever the main folder we are having, please change that main folder as a Spark.
yes, I did the same and then applied the path.
Yeah, I will go to the path. Just wait for a few seconds. If you are getting the subfolder, then please just change the subfolder path as a Spark. If you are not getting any subfolder with the same name, then you need to replace the main folder name with the Spark. Same information I kept here. Rename the folder name from this name to Spark. In this folder, you need to see all the subfolders and whatever the folders we are having, bin, conf, lib, all these folders by default you can able to see. For that main folder, you have to give it as a Spark. Okay. Now next step is nothing but again we have to define the environment variables and as we discussed earlier, if you want to open the environment variables, go to start button, search for environment variables. And here click on environment variables. Here we need to provide the variable name called as a Spark underscore home. Just give it as a new. Give name as Spark underscore home. That also given in the steps. Whatever the name I given here, Spark underscore home. Please give that name here. Now you tell me, coming to variable name, what's the value we need to pass? People, you try to give the answer. For example, if you are maintaining the Spark folder within the downloads only, then what you have to do, you need to provide the downloads. Go to downloads, double click on this, double click on Spark, then give this path. If you are maintaining your Spark folder within the downloads only, then you have to give the path for the downloads. You have to give the main folder. Within that, you have to provide the folder name called as a Spark. But what I told you, for your benefit, better you can able to move this Spark folder to your D drive or E drive or any other drive. For example, if you are following my session, then what we need to do here in my system, in the D drive, I copied the Spark folder. Then we need to give this path. Indirectly, wherever you are maintaining the Spark folder, that is the path we need to provide. That is the information. So we are given the variable name as a Spark underscore home. Then we are given the variable value is nothing but in whatever the path you are maintaining your Spark folder, either downloads folder or C drive or E drive or F drive, in whatever the path you are having the Spark folder, that path we need to provide here. After that, just click on the OK button. With that, what we are doing here, you are creating the Spark underscore home. After that, again, we need to double click on the path. We need to double click on the path. Here, click on new. Here also we need to give percentile Spark underscore home percentile / bin. So this is the variable again we need to assign in the path and so earlier also for Java also we did the same thing. We need to create the variable called as a Java underscore home. After that, we need to add that into the path. In the same way, we need to create the one more variable called as a Spark underscore home and we need to provide that value into your path variable. So same thing we are repeating whatever we did in the Java to the Spark also. Here we have to give it as a percentile Spark underscore home percentile / bin. This is the value we are adding on top of your path variable. Again, I mentioned the step also here. If you see, double click on the path. In the path variable, you have to give it as a percentile Spark underscore home percentile / bin. Complete value you can able to copy paste. With that, you can able to add the one more variable on top of your path. Now, after doing all these steps, only very simple. Just we need to open the again command prompt. In the command prompt, just to give the command called as Pyspark. Give command called as Pyspark. So once you are going to give the command as a Pyspark, in 30 seconds or 40 seconds, you can able to get the window like this. So this is the way you can able to get the window. So here you can able to see Spark version which we installed. and after that you can able to see the Python prompt only, because here we are giving the Pyspark. Pyspark is nothing but Python plus Spark. Indirectly you are working on the Spark by using the language called as a Python language. For that reason here you can able to see the Spark version. After that you can able to see the Python version. After that here you can able to see the greater than symbol. Now you tell me what is the meaning of this prompt, if you remember.
Python.
This is the Python prompt. If you remember, as part of discussing about the Python, we worked in the command prompt. Just when we given the Python command, you can able to see the prompt like this only. Whenever we are giving the Pyspark, you can able to get the messages like this. After that, you can able to see the Python prompt like this. Once you can able to see this kind of window, with that we can able to say in your system Pyspark installed properly. So all these are the steps we need to follow as part of our Pyspark installation. Now, just I'm going to open for the questions only. If anyone facing the issues out of all these steps, please let me know.
Sir, I got a .exe bin Java was unexpected at this time while giving command in command prompt.
You are giving the, for which command only you are giving Pyspark or you are giving the
Pyspark,
Java?
sir. Yeah, Pyspark. Java it runs successfully, but Pyspark.
Okay, so just I'm giving the permission to you. Can you please share your screen?
Yeah, sure, sir.
Yeah. For other people, if any one of you completed the installation, you can able to drop for the day. You can able to drop from the meeting only. If anyone facing the issues, please stay back. I will check those issues.
Sir, we have 11:45 class at.
Yeah, that I will update in the next 20 minutes only. So I'm expecting some call in my office. I will give the confirmation in the next 20 minutes. I will ping you in the chat. If we don't have the 11:45 class, we'll have the 2:30 class. I will give the update in the Telegram group. Please wait for that.
Okay, thank you.
Okay. Yeah.
Sir, how to rename after unzip the Spark folder, sir?
Just right click on the folder and give it as a rename. That's it.
I'm not getting those options, sir. That's why.
Okay, just 1 second. We'll check it and so can you please give the Java version? Whomever shared the screen. Okay. Now can you please go to the environment variables? Okay, just 1 second. So why you are giving? No, so mistake, right? So coming to Java home and you don't give the file path. Here you have to provide the path of your installation folder. So this is your downloads path. You got my point? As part of installation, it is installing into a particular folder. That folder path you need to provide. Can you do one thing? Can you please go to the C drive? I think in the C drive only mostly it will install. Please go to your C drive. Yeah, go to program files. Go to program files. Yeah, now here, please double click on the Java. Yeah, double click on JDK. Oh yeah, this path you have to provide. Okay, can you click on OK now? Okay, 1 second. Can you please show me the Spark underscore home here? Yeah, this is fine. Can you please show me Spark underscore home variable? No, cancel this. Okay, scroll down. Yeah, can you open the Spark underscore home? Okay, you kept it in the D Spark. Okay, can you please go to the D drive Spark folder? D drives. Yeah, double click on that. Double click on the Spark. Yeah, perfect. And now click on cancel and now go to the command prompt. Click on OK here. Okay. Okay, now close this one and open the fresh command prompt. Okay, now give the Pyspark. Yeah, now it's working on it. Just wait for 30-40 seconds. It will populate that window. So you did the mistake for you given the wrong path for the Java underscore home. That's the reason you given that error.
Sir, for me, after giving the Pyspark in command prompt, I didn't get the
Yeah, click on
Pyspark.
allow access. Yeah, we'll check it in 1 second. Yeah, click on
Okay.
allow access. Yeah, it's working for you. Okay. Who is that? Can you please tell me the name?
After
Someone else,
giving the
Vishnu
Pyspark
Priya.
in command prompt. Yes, sir.
One second, I'm
After
giving the
giving.
permission. Yeah, one second, I'm
Okay.
giving the post permission. Okay, can you please share your screen?
It's showing like this. Sir.
Can you scroll up? Can you please go at the top, scroll completely up. Okay. Hadoop underscore home folder is not available. So if you see the error, file not found exception only. So can you please open this one? So can you open the environment variables once?
Okay.
Okay. Below section, can you please open the Spark underscore home? Can you please scroll down, scroll down, scroll down. Scroll down. Please open the Spark underscore home.
Spark underscore.
Here, please open the Spark underscore home variable. In the below, you can able to see that variable. Can you please scroll down?
Okay.
Yeah, double click on the Spark underscore home. Double click on
It's
that.
not opening. It's not opening. Sir.
It's not opening. Okay. So Vishnu quality thought TS Spark. Okay, can you please go to this folder once?
Okay. This one.
Okay, open that. Okay, everything. Okay, can you please go back to the environment variables one more time? Okay, can you open the path variable here? Path. Scroll up a little bit. Yeah, double click on that. Yeah, double click.
Not opening, sir.
She's in wrong thing, sir. Edit system variables. You should click. You clicked on edit, enter environment variables for your account. In Windows, go and type edit environment variables.
Take
The
the first
first one
one.
you have. Yes, sir. Thank you.
Okay.
Click on environment variables one more time. Okay, now can you scroll down? Okay, this one is clear. Okay, cancel this. Cancel. Okay, can you please open the path? Path. Okay, here where is the Java underscore home? So I ask you to add the Java underscore home slash bin also, right? So you added the Spark underscore home slash bin, but here we need to add the Java underscore home slash bin also. So please add that. So I think with that it will work.
Okay.
Percentage, you can copy paste instead of typing, better copy paste. Okay.
Yes.
So after adding this, please close this variables window and please close your command prompt. After that, you can able to open the new command prompt. There you can try one more time.
Okay.
Okay.
Sir, I have installed, sir, but in the command prompt, when I give Pyspark, it is actually opening a Word document for me. Print hello is there. It is not in the command prompt. I'm not seeing Pyspark thing is coming.
Okay, can you please share your screen?
Okay,
I'm giving the permission to you.
Okay, sir.
I given permission to you. So
Yeah. I'm sharing, sir. Not seeing option for share entire screen. Hope you are seeing my screen, sir.
Yeah, I'm able to see. No, wait. No, can you give the Pyspark? Okay, click on enter. Just wait for a few minutes. It will take some time to load it.
It is opening Python Word document. Like this, it is opening, sir.
I'm not seeing any Word document on your screen.
Okay. I'm not seeing option to share entire screen. Are you seeing my screen now, sir?
Yeah, I'm screening your black window only.
Okay. How to share entire screen, sir?
Yeah, as part of sharing, you can able to see that info.
1 minute, sir.
Otherwise, can you do one thing? So can you please show me your environment variables quickly? I will see that once.
Okay, sir. Are you seeing, sir, my environment variables?
No, I'm not seeing your screen.
1 minute, sir.
Yeah, now I'm able to see.
Okay, sir.
Yeah, can you please go to the environment variables once?
I kept the name as downloads Spark-3, sir. Here only bin folder is there.
Okay, can you please show me that once?
Here only bin is there, sir.
Downloads part 3. Okay, so can you please go there once? Can you please show me the path once?
Okay.
Okay. Can you open the path variable?
For Spark also same thing happened. Command prompt, it did not open. It's opening a Word document.
Can you do one thing? Can you please remove that -3 and try it once?
Okay, sir.
In the path, remove the -3, just give it as a Spark only. And here also just give it as in the Spark underscore home also give the only Spark. Not here. Can you please go to
Okay.
the Spark underscore home?
Okay, sir.
So remove the -3. Click on OK. Okay, click on OK. Now go back to your downloads folder. Yeah, rename it as a Spark only. Okay. Now can you please open the new command prompt? Can you please give the Pyspark now?
So for me, it's showing the same method.
Yeah, we'll check it out. Just 1 second.
Same, sir. Will it impact somewhere, sir? I can't work from command prompt.
Yeah, actually, we need to do some. We are planning to do some practicals by using this command prompt, or we are doing practicals on the PyCharm also. So
Okay.
if it is not working, might be won't able to do those practicals. So actually, here intention is I want to show you all the options. One is from the command prompt how we can able to work on the Pyspark. Second option is how we can able to work by using the PyCharm. Third option is we are going to discuss about the Databricks. So with the help of the Databricks also, we are going to do some practicals on the Pyspark. So all these three options
Databricks will work for me, sir. Databricks, I have done lots of coding. PyCharm is also working, sir, for me.
Okay, then you can do the practice on the PyCharm.
Okay, sir. Okay, sir. Thank you, sir. I will try to fix this. If not, I can use these two, right, sir? PyCharm and Databricks. Thank you, sir. Bye-bye, sir.
Thank you.
I'm also facing same issues.
What's the issue?
Pyspark not working.
Yeah, can you please share your screen?
Sir, this Java one.
Yeah, please continue. For Manohar, I'm giving the access to you. Can you please share your screen?
Okay.
Sir, for the Java one, the first step itself, after completion of that installation, I clicked on that environment details. I added that environment,
My
sir.
screen is visible, sir.
Now, 1 second. Some other person is talking. Yeah, please continue. Other person.
Sir, added that. If I'm in the path, if I'm double clicking that, again it's opening the same like variable name and value one, sir. It's not getting like all the details like new edit, some other tab coming, right, sir? That is not coming.
Okay, just 1 second, Andy. So we'll see this person issue, then I will come to you. Just wait
Yeah.
for a few minutes. Okay, so can you please go to the variables and once? So
Yes,
Java
yes.
home, you get, yeah, scroll. Why you give the Spark home above? You have to give the Spark home below, not above. So
Yes.
Java home, where you given below, right? In the below section, you given the Java home. In the same way, below only you have to give the Spark underscore home. In the below section, in the system variables below section.
Yes, sir. No, I'm given, sir. Spark home.
Now, why you given the percentage Spark home here? Here you have to give the path, right? In
Yes,
the
sir.
Spark underscore home, you need to provide the path. In the path, you have to provide the slash b. Here you given correct. This is correct. Can you please cancel this? This is correct only.
Okay.
Can you please scroll down? Here in the Spark underscore home, what we need to provide? You need to provide the path of your Spark folder.
Can I delete, sir?
Now you can edit. Click on edit. Click on edit.
Delete, yes, sir.
You deleted. So why you to delete? You can click on edit. No? Okay, so okay, you can create it again. Click on new button. Okay, now give Spark underscore home. Spark underscore home. Okay. Now with the variable value, please give the path of your Spark folder. Double click on Spark. You have to give the till Spark cut, not up to here. You have to give till Spark. Double click on the Spark here.
Here.
Double click. Okay. Now please copy this. Take the path here from the above. Copy this. Okay. Now can you please go to environment variables? Okay. Paste here. Yeah. Now click on OK. Click on OK. Okay. Yeah. Now here also click on OK. Please open the new command prompt. Please open new command prompt. No, please open the complete new window. It's working and it's loading. So wait for a few seconds, it will come. Okay.
Okay, sir. Thanks, sir.
Yeah, other person.
Can I share my screen, sir?
Yeah, please. Click on allow. Click on allow this. Okay.
Yes, sir. Hello, sir.